This lecture is on the covalent bonding Lewis dot diagrams. We're drawing diagrams to illustrate the bonding between nitrogen and hydrogen in this case. Covalent bonds are a sharing type. They share electrons because the difference in electronegativity between the two nonmetals is very similar. Why is it very similar? Because they both are nonmetals, and nonmetals tend to be smaller and have a high attraction for electrons. They're located, okay, of course, in the periodic table on the right. Even though hydrogen certainly is on a nonmetal, it's located on the left-hand side because of one valence. It really belongs with its other nonmetals who are above the staircase in this case, all the way over here. Notice they love to become negative, and these guys with their high electronegativities, okay, are forced to share because no one's that much stronger than another to yank the electrons away. The difference isn't very similar, so therefore you can't have a transfer, unlike a ionic compound where it's a metal bonded with a nonmetal to create ions. These guys share electrons to fill their orbitals, become like noble gases. So get back to it. Let's start with valence electrons. We're going to start with N. It's normally the more electronegative atom goes in the middle, but I think in terms of how many bonds N makes. If I look at the periodic table again, and I look for some clues here, I'm going to see that N, okay, has 5 valence electrons. 2-5, okay, or in group 15, take the 1 away, has 5 valence. It needs, count them with me, 1, 2, 3, very good, okay, electrons to have a stable filled octet. That's the octet right there. And when it gets its 8, it's stable as neon. So I know to put 5 dots. I put out the valence electrons. We'll put them out as black. Now, you can put them anywhere you like, all right? And I'm going to put out 5. Now, what I'm going to do at this point is I am going to put out my H's. Now, why did I know nitrogen go in the middle? Because I know it needs to make 3 bonds. A bonding in covalent is a pair of electrons. I know that this guy needs 3 more electrons, therefore it makes 3 more bonds, so therefore the N had to go in the middle. But going back to hydrogen, all right, let's go back to hydrogen. Let's go find it on the periodic table. Now you may already know, but I'm just showing you as we go across the periodic table, and we know that it has 1 valence electron. So clearly, all I have to do here is put an H, and let's change the color to keep it nice and simple. H is here, and this hydrogen is here, this hydrogen is here, and this hydrogen is here. Notice I didn't put the hydrogen where the 2 electrons are already there. They're already filled. So each hydrogen, let's say, brings its own electron, its own valence. So what I'm doing is I'm putting out all the valence. Okay, nitrogen has 5 valence, and each hydrogen brings 1 apiece, and since there's 3, okay, there are 3 electrons for a total of 8 electrons. And these 8 electrons make every element stable. This nitrogen feels like it gained 3 to go from its 2-5 to that 2-8, that octet. And this hydrogen feels like it has 2. This hydrogen feels like it 2. So all the hydrogens went from a configuration of 1 to 2. Well, this is helium, okay, and this is neon. They both became as stable as their noble gas counterparts in terms of electrons by sharing electrons, being forced to share. Okay, well, there's more information that covalent bonds have, and you should look at the other covalent lectures here. But I will mention that because these have 2 different electronegativities, these bonds in the middle, okay, are something called polar bonds. Polar bonds is unequal sharing of electrons. So there's 4 polar bonds. What does that really mean? Well, it means that if I look at one of these ends and see how it bonds with an H, that pair of electrons, let's make the black here, let's make it represented as green, goes here, and we can see that they're sharing unequally, okay? and this side of the bond has that partial negative, and this side's partial positive. That makes something called poles. And we say dipole is another word for polar bond, sharing unequally. But that's the basis. Now let's do one more, okay? And I'm going to go a little faster as we do this, okay? So if we do one more, and let's do this, and let's do the bonding between oxygen and water. Let's do H2O. So if I have H2O, I have oxygen, hydrogen. We know hydrogen has one valence. Oxygen, well, if I don't know, I kind of do know. I go to the periodic table, and I go find it, and we move across the periodic table, and we find that it has, it's 2-6, it needs 2 electrons. So my friends, it needs 2 more electrons. It loves to gain 2, but we don't really gain 2 when it bonds with hydrogen, another nonmetal. It shares 2. So it has 6 valence, it needs 2 more. So back to where I was. I know that oxygen has 6 valence, it's 2-6. It needs to become 2-8, so it needs 2 more electrons. Hey, it's going to make 2 bonds. Hydrogen makes 1 bond, so my oxygen is more central. Put out the valence. And there's my 6. And of course, I'm going to put out, okay, the 1 for each hydrogen. And there it is. Now, you could have drawn it this way. Oxygen with 2 dots on top, and then 2 here. And that would be perfectly fine. Notice the oxygen is sharing 8. Notice the hydrogen is sharing 8. I'm sharing 2, okay? Sorry. And that's how we do that. Look for the other tutorial on bonding nonpolar and polar bonds and more advanced Lewis dot diagrams.